Hello student, my name is Nimish Prabhakar. I am Assistant Professor at LJ Institute of Engineering and Technology in Instrumentation and Control Department. Welcome to Process, Dynamic and Control lecture series. Today we are going to discuss about different control scheme. In my previous lecture, we discussed about the dynamic behavior of heat exchanger. Now, in this lecture, we study about the control scheme. So, to understand this control scheme, now we take one example of heat exchanger like a simple tube and cell and tube type heat exchanger. We know cell and tube type is the most common type of heat exchanger. Now, liquid run through tubes and steam through cell surrounding this tube. That means in this type of heat exchanger, this is a one cell, and in this cell number of tubes. Now in that tube the liquid is run and this steam is given to hot this fluid surrounding of this fluid. So this is a very simple type of heat exchanger. Now to here understand the control scheme. So control scheme is the basic purpose of control scheme is what? So here our control variable is outlet temperature of fluid. That means here this is a inlet and this is a outlet. We have to control the temperature of this outlet fluid. That means in the inlet we give water and at outlet we get water. Like in inlet the water temperature is low and we have to increase the water temperature of this water. So here we have to control the outlet temperature. So this is a main purpose of this control scheme. So there are number of ways to control this outlet temperature. So in this lecture we discuss about that number of ways that control the outlet temperature of this fluid. So the exit temperature or the outlet temperature of fluid can be controlled by there is a number of ways. First one is changing the temperature of the other fluid. That means that other fluid temperature we can change. That means here the other fluid is the steam, so we can change the temperature, or by giving the other fluid we can change the temperature. The second one matter is the changing the heat transfer coefficient, and the last one is the passing part of the fluid around the exchanger. So some fluid we can pass around the exchanger and we can also control. So now to understand this control scheme, we start with the first one control scheme. So first one control scheme name is the throttle steam flow. So in this method we understand what is throttling and what is throttle valve. So throttle valve are a type of valve that can be used to start, stop and regulate the flow of fluid. Like one valve that regulate the flow, like we have to start, we have to stop, or we have to regulate the fluid. So we use throttle valve. So here the example of throttle valve. This is the one fluid go in this second one side. So by using this throttle valve, fully open, fully close and partial open and partial close, we can control this fluid. That means the flow of this fluid we can control. So this is a function of throttle valve. So here we place the throttle valve at the steam side. That means like this is the arrangement of this scheme. In this scheme, we place one valve at the inlet side of the steam. So we place one valve at here. So this is the inlet steam flow, and this is the outlet of the steam, and this is the inlet flow of the fluid, and this is the outlet flow of the fluid. So we our aim is to control the temperature of this outlet fluid. So we place one controller here. That controller open and close this valve, or in other words, regulate the flow of steam by using this valve and control this temperature. So now we see, in this controlling system, one control valve is placed at the input side of the steam like this, and that valve controls the inlet flow for controlling the temperature of outlet fluid temperature. So here maximum heat transfer rate. So maximum heat when transferred, when the valve is fully open, at that time maximum heat, that means maximum steam, is transferred in this. At that time the temperature of outlet fluid is maximum. So at 100% maximum valve opening, this is the maximum cell pressure and maximum heat transfer rate and maximum output temperature. So this is a very simple control scheme. In this control scheme, we place one valve at the steam flow, and this valve is a throttle valve, and by controlling this valve, that is, this is a one controller that control this steam valve and regulate the temperature of this outlet fluid. So this is our aim, to regulate the temperature of outlet fluid. So this is the first method to regulate the temperature of outlet fluid. Now second method is the throttle condensate. So in this method we control this condensate. So first of all, question occur in mind, what is condensate? Condensate, that is nothing but this steam is converted into liquid. So we control that converted liquid by using this valve. That means in the steam, this steam is enter in this cell like in this drum from this direction, and when the temperature of this steam is reduced, so that steam is converted into the liquid. So now this liquid is the flow, and that means the out from this valve. So we can control this liquid, then this outlet flow of this liquid by using this valve, and for our aim is to regulate the temperature of the outlet fluid. So we use one valve at here. So this is called throttle condensate. So we understand here, when temperature is too high, valve is closed a little more, which cause condenser to cover a few more tubes. That means when the temperature of the fluid, when the temperature is too high, at that time the valve is closed. At that time we close this valve. So this liquid is covered more number of tubes, but due to this, when we close this valve, that means hold up time for the condenser is more, then steam condensate first and the level will change, then the level will change, so process is slow. So here, due to this, when we hold up this valve, then that means when we close this valve for more time, then at that time the process is slow because of the holding of this valve, because this steam first convert into the liquid and they try to reduce the temperature of this flow. So by using this valve we can control the temperature of this outlet temperature. When we require, that means we require the low temperature, at that time we close this valve for more time. So this cold steam is try to reduce the temperature of liquid. So at that time we get the low temperature this time. And when we want to increase the temperature of the outlet fluid, so at that time we open this valve for more time. So steam is flow more time surrounding this fluid. So at that time we get the outlet temperature is high. So by opening and closing of this valve we can regulate the temperature of fluid. So this is a throttle condensate method. When flow of process fluid is more, valve is open to explore the heat transfer surface area, and this makes process fast. That means when the flow of this fluid is more, at that time we get here the high temperature. So this is the second one method. Now third one method is the bypass method. Now as name suggests, bypass, that means we pass some water or some fluid from this direction. So this is a one way and this is a bypass way. We know the bypass highway, same as this is our main highway and this is a bypass highway. So in this scheme we give some inlet flow of water to the outlet of this exchanger. That means some part of this inlet water we give to the outlet of this heat exchanger. So by that way we can control the temperature of outlet water. So see, this is a simple arrangement, bypass. Here we put one valve, this is a bypass valve, and this valve is controlled by this temperature controller. That means when we want more temperature, at that time we do close this valve. So at that time the flow is only this direction. And when we want to reduce the outlet temperature, at that time we open this valve. So the cold water is mixed with this hot water and reduce outlet temperature. So by opening and closing of this valve we can control the outlet temperature of this system. So to understand this, if the control of temperature is critical and exchanger is oversized like a big, the fast bypass or bypass control scheme is used. About the 10 to 30% of process steam is bypass and blend. Blend, that means mix with the hot fluid from the exchanger. That means, as we discussed earlier, this is the 10 to 30% of this fluid is mixed with the hot water of this exchanger. So we can reduce the temperature. The process opening the control valve decrease liquid outlet temperature. So process is reverse acting. So this is a bypass valve. Now we discuss about the three-way valve. So this is a simple figure or symbolic figure of three-way valve. This is nothing but the simple symbolic figure of the heat exchanger. Like this represent our heat exchanger. This circle represent. This is a hot fluid TH1 flow, and this is a TH2. This is a fluid 1, and this is a cold fluid TC1, and this is a cold fluid outlet of the cold fluid temperature TC2. This is the hot fluid temperature TH1 inlet temperature, and this is a hot fluid temperature TH2, and this is a cold fluid temperature inlet cold fluid temperature TC1, and outlet cold fluid temperature is TC2. Here we place one valve here, and this valve is known as three-way valve. How? Because here three-way. First is the hot fluid inlet, this is a hot fluid outlet, and some water is also we pass in this direction. So this is a bypass way. So this all done by this one valve. This is nothing but the bypass method, but by here to control bypass method we use three-way valve. Okay, here TIT is nothing but the transmission of the temperature, because this temperature controller. So here TIT is a one type of sensor that measure the temperature of the outlet and that transmit to the controller. So first the outlet temperature is measured by this and transmit to the controller, and this controller control this three-way valve. So this is a simple arrangement. Now this is a three-way valve. So aim is our fix to control the outlet temperature. So for this controlling outlet temperature we use three-way valve. So we see the limit within which the process temperature can be controlled are a function of the nature of load changes. In many cases, the process time lag in the heat exchanger is too great to allow for effective control during load changes. In such case, it is possible to circumvent the dynamic characteristic of the exchanger by partially bypassing it and blend the warm process liquid with the cold process fluid. So this is nothing but the simple bypass method, but here we use three-way valve. So to control this temperature, this controller open and close the this valve. That means the increase and decrease the inlet flow, or also it increase or decrease this bypass flow and regulate the temperature of this outlet flow. So what are the advantages of three-way valve? So first one advantage of this three-way valve is increased speed of response. That means the process response in the process speed is increased by this three-way valve. The cost saving. So this is another example of this bypass valve. There is a few disadvantages of this bypass valve. Like first one disadvantage is lower temperature difference between supply and return water. And the second one disadvantage is the increased pumping cost. So these are the disadvantages of three-way valve. Now last one method, controlling scheme, last one is the two-way valve. That means here we use two valve. See, first of all we see the some limitation of the three-way valve. Then after we see the two-way valve method. So first one limitation of the three-way valve is the use of three-way valve is not recommended for high temperature or high pressure differential service. So this is the first one limitation or the disadvantage of three-way valve. And second one limitation of the three-way valve is the hollow plug design of three-way valve also contribute to their limitation, because it makes this valve more sensitive to thermal expansion and more difficult to handle than are the solid plug. So these are the second one disadvantage. This is because the thermal expansion, the valve is not capable like other valve solid plug. So these are the limitation of the three-way valve. So instead of this three-way valve, we use two-way valve and increase the efficiency of the system. So how it can increase? Now we see the method of this is a two-way valve method. So this is the figure of the two-way valve. Here we use two valve. First valve is here and second valve is here. This is, we know this is the bypass valve. As we discussed in the bypass method, same as this is the bypass valve, and this is the exchanger valve. This we use here. So by using these two valves, we control the temperature. That means the outlet fluid temperature we control. So here the fluid in from this direction and fluid out from this direction. Same as the steam in from this direction and steam out from this direction. Now first one is here our aim is to control the temperature, and for this we use two valve. So first one valve, this is a master valve, it is a bypass valve. So for this controller control both of these valves. That means it control the bypass flow of inlet water and also control the control the direct flow of fluid in the exchanger. So by this two-way bypass valve, we can reduce or increase the temperature of the outlet water. So this is a simple arrangement of the two-way valve. Okay. So in this lecture we discuss about the basic method of controlling of the temperature, controlling of outlet temperature. So these are a different scheme to control the outlet temperature. Okay.